Hello and welcome to this video on the ICND1 series. In this video, we will look at switching. We will also look at the types of switching that we have, and we will look at the functions of a Cisco switch. So let's get started. What is Cisco switching? Switches were invented in order to segment the collision domains, as we have talked about in a previous video. And what is a collision domain? If you remember, a collision domain is a part of a network where you can have collisions. So when you have devices that are connected to different ports on a switch, each of these devices are in their own collision domain, unlike a hub, where all the ports of the hub are on the same collision domain. That means that when you send multiple packets across a switch, you will not have collisions. So what are the properties of a Cisco switch? The first and the most important property of a Cisco switch is that it segments collision domains. The second property of a Cisco switch is that it switches in hardware. In the evolution of switches, when bridges were first created to segment collision domains, network segmentation was done in software. So we have the bridges running in a software that was used to decide where frames would be sent. But in Cisco switches, we have what is called ASIC, which means application-specific integrated circuit. And these are what you call hardware circuits that are used to perform the switching, and that makes them faster than using software switches to perform switching. If you need to identify the difference between a switch and a bridge, one of the major differences is that bridges were originally designed to use software for bridging, while switches use hardware for switching. Another difference between a switch and a bridge is that a switch has a higher port density than bridges, in the sense that back then, when bridges were in use, we had really small number of ports on the bridge because bridges were really expensive devices that were brought into segments, collision domains. So what you would normally have is that you would have a hub that's connected to many devices, and then when the collision domain seems too large, we bring in another hub, and then you use a bridge to connect both hubs. So the problem was bridges were expensive and the port density was really small, and they switch in software. Meanwhile, switches have a higher port density and they switch in hardware, and that makes them faster. So that's the evolution from hubs to bridges and then to switches. Now, let's move on and look at the types of Cisco switching. A switch is a layer 2 device. That means that it sends frames from one port to the other. If you remember, at layer 3, we have packets. At layer 4, we have segments. But at layer 2, we have frames. So what happens is that a switch gets a frame and tries to switch it to another port based on the properties of that frame. And we have been able to determine that the property of the frame that the switch is used to make that decision is what is called the MAC address. And if you remember, a MAC address is a 48-bit address that is used to uniquely identify a network interface. The types of switching that we have on a Cisco switch depends on the way a switch forwards the frame based on the information in the MAC address. The first type is the store and forward kind of switching. And what happens is that the switch actually takes the whole frame, including the data you want to send, and stores it in its memory, and then based on the information in the frame, forwards it. So it stores the frame and then forwards it. The second one is the cut-through. The cut-through was introduced because the store and forwarding method actually takes a lot of time to implement, because when you store the frame first and then forward it, you have to have a lot of memory space to forward, and you have to completely store it before you forward it. So what the cut-through does is that the switch just tries to find the information it needs for forwarding, which is usually the destination MAC address. So when the switch gets a frame, it checks the frame, and it does just up to the part where it finds the destination MAC address. And then it decides that based on the information, I can forward it to the destination so it does not bother trying to store the whole frame before forwarding it. It just forwards it as soon as it learns about the destination. And in the destination MAC address in the frame is a 6-bit address that comes in just after what is called a preamble. So you have the preamble, and then you have the destination MAC address. So when the switches use a packet, it gets the preamble, it stores that, and it gets the destination MAC address. And once it gets this information, it looks up its MAC address table and tries to decide where to send the frame to. It doesn't wait to store the whole frame like you would have done if you have it in store and forward. Now, Cisco continues to create faster switches. We now have a case where you can actually have very high memory, and you do not need to do cut-through switching in case you need to make a sophisticated forwarding information based on other parameters in the frame that are not part of the MAC address. So the really smart engineers at Cisco decided to optimize the first two types of switching and decided to say, instead of storing the whole switch or just looking at the destination MAC address, what if we store the first 64 bytes of the packet? So they stored the first 64 bytes. And the first 64 bytes, that's where you have most of the information that you need to send any kind of packet or make any kind of decision. And that's where you have most of the errors. So once you can store the first 64 bytes, you really do not need to store the whole frame. And that's the kind of switching that is now being used. Now, let's move on to the functions of switches. There are three major functions of a switch. The first function is that it should learn and store MAC addresses. The second function is that it should be able to forward and filter frames based on what you have configured on the switch. So it forwards and filters based on its MAC address table. It can also forward and filter based on security measures like access lists and port security. We will look at some of those when we move on to configuring the switch. And the third one is to avoid loops. And you avoid loops based on the protocol known as the spanning tree protocol. The spanning tree protocol is part of the ICND2 exam, so it's beyond the scope of this ICND1 exam. Now let's look at how a switch can learn and store MAC addresses. Switches learn and store MAC addresses by using the source MAC address of frames that they receive. I'm going to explain this now. So when you have a switch and it has many ports, it keeps what is called a MAC address table. And a table is basically a list of MAC addresses and the ports that it belongs to. So if I have a MAC address that says 1111.1111.1111, and I can say it goes to fast Ethernet 0/1, and then I could have this other MAC address that says 2222.2222.2222, and it goes to fast Ethernet 0/4. In the MAC address table of a switch, you can actually find a long list of MAC addresses and ports. And how does it populate that list? What happens is, when you have a packet, if we have this on the fast Ethernet 0/4, and you have another computer on fast Ethernet 0/7, if the computer on fast Ethernet 0/4 wants to send a message to the computer on fast Ethernet 0/7, as you know, it would first ARP for the MAC address on the computer on fast Ethernet 0/7. And when it does this, it would send a broadcast, and a broadcast is identified by the destination address of the broadcast. In this case, the destination MAC address would be all ones for all the 48 bits, so it would be FFFF.FFFF.FFFF. So that's the destination MAC address. While the source MAC address would be the MAC address of the computer itself. So it's saying the source is from me and the MAC address is 1121.abc1.378e. Now, when the switch receives that frame, it would be able to learn that I got a frame with a source MAC address of this from port fast Ethernet 0/4. That means that these MAC address must be at fast Ethernet 0/4. So it goes to its MAC address table and then ties this MAC address to fast Ethernet 0/4. Now the destination MAC address is broadcast and it does not know which destination it is. So what it does is that it forwards it to all the ports except the ports that it learned it from. So every port hears from fast Ethernet 0/1 to Fast Ethernet 0/3 and all the way to Fast Ethernet 0/24 if it's port 24, except the Fast Ethernet 0/4 ports, all receive the ARP broadcast asking for the MAC address. And then Fast Ethernet 0/7 would now respond with its own MAC address saying that, hi, this is my MAC address. And that frame, when it gets to the switch, we have a source MAC of this computer's MAC address, which will be 2234.4E4F.5BC6. And the destination will be the MAC address of the PC on Fast Ethernet 0/4, which can find it from the first frame that it got it. So it would set the destination to be 1121.abc1.378E. So what happens then? When it gets to the switch would learn this based on the source MAC address and the fact that it received it on Fast Ethernet 0/7. It's going to use its MAC address table and tie this MAC address to Fast Ethernet 0/7. Now, it already knows the MAC address of the destination because it has already entered Fast Ethernet 0/4 in its MAC address table for this MAC address. So what's going to happen is that it's just going to send the message directly to Fast Ethernet 0/4. This time, it wouldn't send a broadcast to everyone. So through this ARP process, the switch has been able to learn 2 MAC addresses. Now you have a switch that has 24 ports. The switch can easily learn about all the MAC addresses that are attached to those 24 ports using the source MAC addresses of frames that it received from those ports. So in summary, a switch learns MAC addresses based on the source MAC addresses or makes its forwarding decisions based on the destination MAC addresses. We're going to look at how this happens on a live switch in a subsequent video. So in this video, we have been able to look at Cisco switches and their characteristics. We have also been able to look at types of switching, which are the store and forward switching, the cut-through switching, and the fragment-free switching. And we've been able to look at the functions of a Cisco switch, which is to store and learn MAC addresses, to forward and filter frames, and also to avoid loops based on the spanning tree protocol. Thank you for watching.